session. Once again, welcome to this session here. This is the fifth session that we are engaged in of 9 sessions. And I want to thank you for being quite regular and attending all the classes. Undoubtedly, you will benefit a great deal from whatever you learn here. Okay, so we will go straight to the problems at hand today. This is session 5. Okay, Lulama, I think you've got your mic on. Can you please put it off, please? Lulama Mukhari. Okay, the first question says, the diagram shows 2 parallel lines with 6 points indicated. Okay, the points don't seem to be very clear. So let's just get them. You got one here, one here. So there are 4 points in the top line and 2 points in the bottom line. Okay, how many triangles can be drawn with their vertices chosen from these 6 points? Right, so quite evidently, you'll have to have, you could have a triangle maybe with a vertex on this line. It's not possible to have no vertices in this line. That's not possible. Otherwise, all 3 vertices will have to be there, and that wouldn't give you a triangle, okay? So you have to have at least 1 vertex here. So you can have 1 vertex on the bottom line or 2 vertices. Let's take them, take 1 vertex at a time. Say with 1 vertex on the bottom line. And so suppose we have this vertex here. Okay, then what do we have to do? We have to choose 2 more vertices. We need to choose four vertices. I'm sorry, 2 vertices from 4 to create a triangle. Right? Triangle has got 3 vertices. 1 is here, 2 have to be here. So if you choose 2 vertices from here, suppose you give the names A, B, C, D to those vertices, then you could have 2 AB or AC or AD. So all those with A in it. Okay, now let's take all those without A in it. Start with B. There are BC or BD, right? And then you take one without either B or C, A or B in it. So you can only have CD. So there are 6 possibilities. Right? So you could choose 2 vertices in 6 ways. All right. So that means there are 6 triangles. With the tick, right? So with this vertex here, you've got 6 triangles. Now you could do exactly the same thing for the next point here, right? And now if I call this double tick, also for the same argument, there are 6 triangles with double tick. So it means that therefore you've got 12 if one of the vertices is on the bottom line. In the line below. But then you can possibly have, instead of just only one, if exactly one, right? If exactly one of the vertices is there, you're going to have 12 triangles. But suppose now you've got both vertices are chosen. So how many triangles? Suppose you got two vertices. These are both the vertices on the bottom line are chosen. Then if both are selected, sorry, the writing is so bad. Okay, now you have to choose the third one. The third one could be A, B, or C. Any one of third is any one of A, B, C, or D. Okay, so it means you could have the four triangles here. Four triangles in this case. So if both the vertices are chosen here, you got four triangles. If exactly one, you've got 12 triangles. And those are the only cases because you need to have, you can't have no points on the bottom line. So therefore, altogether you have 16. Okay, because 12 plus 4. So these are the all the possible cases. Answer is 12 plus 4, which is 16. So the answer to this question is there are 16 possible triangles if the vertices are going to be one of these 6 indicated points. Okay, let's get on to the second problem. Okay, the second problem says consider an 8 by 8 chessboard with 64 squares. All right, so I'm not going to draw the whole chessboard, it's going to take too long. But let me at least draw a square that I can draw. Okay, and it's got 64 squares, so you got 8 by 8. In how many ways can you place one black rook and one white rook on two different squares that are on two different rows and two different columns? Okay, let's understand this. Firstly, a rook. What is a rook? I don't know how many of you play chess. But anyway, a rook is another name for a castle. Sometimes we call it castle. Okay, so you've got one black rook and one white rook on two different squares. Okay, let's place the black rook. We can place it anywhere we like. So there are 8 columns, so it could be you could place it in any one of the 8 columns. Okay, so you got the black rook is sitting here somewhere. So suppose the black rook is in some column and we have identified where it is. The black rook. Right. So how many ways can the black rook be placed? the black rook. Lefa, please switch your mic off. Lefa, go. Thank you very much. The black rook can be placed in how many ways? Well, you can place it in any one of the 64 squares. Nothing is stopping you from placing it anywhere. So we have to say in 64 ways. Right, once you place the black rook, now the white rook has to be placed in such a way that, on two different squares, obviously, such that they are on two different rows and two different columns. Okay, in other words, the white rook cannot be placed here. They can't be placed in the same column. Likewise, they can't be placed in the same row. So you're not allowed to place the white rook anywhere in the row in which the black rook is sitting, or in the column. So the white rook now you can't. You don't have a random choice. You don't have a free choice of placing it anywhere you like. You have to avoid these. So how many must you avoid? So that's the question. How many squares must you avoid? It looks as if you must avoid 16, but that will be false, because it's 8 here and 8 here, then this is counted twice, you see. So it is 16, but because you counted this twice, you have to count it only once. It's actually it's 16 minus 1. You'll have to avoid white rook, avoids 15 squares. It can't go anywhere here. It's all no-go zone.
But at most it means,
and there are 15 of them.
0 points for no points.
Okay. So in other words, in how many ways can you place the white rook? White rook can be placed so you have to avoid 15 squares. So it's 64 minus 15 ways. All right, so therefore the two rooks can be placed. The first can be placed in 64 ways, the second in 49 ways. We've done this before. So if you want to place the two rooks together, it's 64 times 49. The first can be done in 64 ways, the second in 49 ways, and the total number of ways is 64 times 49. And that turns out to be 3,136, which you can do by long multiplication. Not allowed to use the calculators. Okay, so that takes care of the second problem. So let me now go to the third problem. Okay, let me clear all these drawings. Now this question, how many positive 4-digit integers between 1,000 and 9,999 inclusive are there that are divisible by 5 with every digit even? Okay. Some of you might have seen this question because I asked this question in different platforms. So what we have to do is to create a 4-digit integer. We have to create one. So what we do is we draw a box. This is how I normally do it. Draw a box, and I need to fill in these 4 spaces here. Sorry, this is looking very bad. So you have to fill in those 4 spaces. And the question is now, how many ways can you create a 4-digit number? Right. Now there are some rules here. It's not divisible by 5. So for a number to be divisible by 5, you know your rules for divisibility. The last digit is either 0 or 5. Okay. So the last digit is 0 or 5. All right. So that takes care of it's divisible by 5. But with every digit even, so all the 4 digits must be even. So in particular, this one here must be even, and 5 is odd. So the last digit will have to be 0. So there's only one way in which you can fill the last digit. I'm going to put 1 down, say that the last digit is fixed. It's going to be an even number, which is divisible by 5. There's only one way in which you can do that. But now the question is, how many 4-digit numbers can you create altogether, where all the digits are even? Okay, so you want all these numbers here, they're all even here too. Right. So how many even numbers can you put here? Well, the even numbers are 2, 4, 6, and 8. Right. But then 0 is also even. We should put 0. But we can't put 0 because it's a 4-digit number, you see. A 4-digit number can't start with 0. Right. Otherwise, it's a 3-digit number. Okay, so you're not allowed to put 0 in the first digit. So in how many ways can you fill the first block? Now that is a question. I need to know how many ways can I fill each of these blocks. Let me put that down in here because you've got 4 ways only you can put it. And I'm going to take the 0 out in this last one because I'm going to put inside the block I'm going to put up. And how many ways can you do it? So I'm not going to put the 0 there. I'm going to say there's only one way in which you can fill the last box. Now this doesn't mean I'm creating a 4-digit, that the number that I've got ends in 1. I'm simply saying that there's one way in which you can fill in this box. There are 4 ways in which you can fill in this box. And this one here, you can put, again, there must be even. You can put 2, 4, 6, 8. Are you allowed to put 0? Yes, of course you can put a 0 here. Right? It will still be a 4-digit number. So you're allowed to put 0 here. So there are 5 ways in which you can fill the second box. Likewise, there are 5 ways for exactly the same reason. You can fill in the third box. But the last one can be filled in only one way because you have to put in 0 in this last box. Right? That's only one way. So we've seen this before in how many ways? So how many such numbers are there? So the answer is you take these different possibilities and multiply them. It's called the first rule of counting, first counting rule, right? Where you multiply the numbers here, where each number is the number of ways in which you can do the first thing, the number of ways you can do the second thing, the number of ways you can do the third thing, and so on. And then to find out the total number, you multiply the whole lot. If you remember, I had the example of roads going to some destination. Okay, so you've got, the answer is 100. Because 4 times 5 is 20, and 20 times 5 is 100. Okay, so that is the number of 4-digit integers that you can create. Well, they are all divisible of 5, and all the digits being even. There are quite a few numbers here. There are 9,000 numbers here altogether, right? Between 4-digit numbers. How many 4-digit numbers there are? The last 4-digit number is 9999, and the first 4-digit number is 1000. But you have to subtract not 1000, but one less than that. So that gives you there are 9,000 4-digit numbers. Okay, well, that's just another thing altogether. It's got nothing to do with the question. So let's move on and get on to the next question, which is question 4. All right, so question 4. Now, here it says if you write the integers 2, 3, 4, 6, 8 in every possible order to form 5-digit numbers, how many of these numbers will be divisible by 11? Before we go on, you might wonder why this is given as number 7 when it's question 4. Right? The reason why this is 7 is that when you go to session 5, we are doing session 5, and if you go to the problem book where all the problems are, this particular problem is number 7. I'm not doing all the problems in that book. Problem book, I'm selecting only some problems from session 5. We don't have time, unfortunately. Otherwise, I will do the whole lot. But we are just selecting some problems. And we do that. And I expect you to go and try the remaining problems to give yourself practice. Okay? And I might have said this before. You can try the remaining problems, and if you get stuck, you can always feel free to write to me. Okay, I'm going to give you my email address if I haven't done it already. You can write to me and tell me, can you please, sir, can you give me ukzn.ac.za? Yeah, you can just ask me, can you give me a hint on how to solve this problem? I might give you a hint, or I might give you the entire solution, depending how I feel. Anyway, let's just get back to this. This is question 7 in session 5 in the problem book, but it's the 4th problem that we are doing. And let's have a look at this problem. It says you're going to use these 5 numbers, 2, 3, 4, 6, and 8, to form a 5-digit number. Okay, let's put down our 5-digit number as we did before. So you will draw a box. You'll make the thing 5 digits. And these five digits are going to be located in that box. 1, 2, 3, 4, 5. Okay. Now I'm going to create a 5-digit number. But what is the condition on these 5-digit numbers? How many of these will be divisible by 11? Now, I don't know whether you know the rule for divisibility by 11. See, so let me tell you what the rule for divisibility by 11 is. Right. The rule is add the 2 sets of alternate numbers. Right? But alternate numbers, I mean, like that one and that one is alternate. That's one set. So one of the sets has got 3 numbers in it. And the other one will have two numbers, the second and the fourth. So those five numbers, you add the two sets of alternate numbers. That's the first thing. Subtract those two numbers. If answer is 11, or in general, a multiple of 11. Could be 11 or 22, or even 0. Then you can conclude then the number is divisible by 11. So that's the rule. Okay, we can try some examples. For instance, let's take for instance 7935. Okay, now you got the alternate numbers. 7 plus 3 is 10. 9 plus 5 is 14. Right? So those are the two sets. Subtract them. Take the smaller from the larger. It's 4. This is not a multiple of 11. The way you write this down is 11 is not a factor of 4. So this number is not divisible. And if you try to divide by 11, you'll get a remainder. Right? But if you try a number like 2, 6, 8, 5, 3, no, say 2, 6, 1. Right. You try this one, you'll see that the alternate numbers are 2 plus 8 plus 1. That gives you 11. And the other alternate is 6 plus 5. Subtract the 2, you get 11 minus 7 is 0. And 0 is a multiple of 11. Why? Because 11 times 0 is 0. 11 times something is 0. Those are the multiples of 11. So this is a multiple of 11. So the answer is yes. 11 goes exactly into this. So you put a factor like this, use a vertical line, and this is the notation for a factor. 11 is a factor. So let's just try this thing. Try dividing by 11. 11 goes into 26 two times. Remainder 4. 11 goes into 48 4 times. 4 11 is 44. Remainder 4. 11 goes into 45 4 times. The remainder is 1. Yes. So 11 goes into 11 one time. So this is a factor. Okay, so this is how you test divisibility by 11. But having sorted that out, oh, I've taken out my. So now we have to put these numbers now in such a way, these 5 numbers, into this box, so that the alternate numbers, when you subtract them, you're going to get either 0 or 11 or 22. It must be a multiple of 11. Okay, so I have to group these. So let's just find out which, maybe the best way to do it is to, let's try to fill in these squares here, the two squares. Let's try to fill in this. Try filling. So what can you put here? You can put the 10. I have to choose two numbers here. So you can have 2, 3, or 2, 4, or 2, 6, or 2, 8. Right? I'm going to take two numbers, and suppose I insist that one of them is 2. Right now, don't have 2 in it. Let's start with 3. You have 3, 4, 3, 6, 3, 8. I'm giving you a way of actually counting or listing these pairs. So I got 3 in it, but I'm finished with the 2s. Now I'm finished with the 2s and the 3s. So I can start with 4, 4, 6, 4, 8. So the 2 3s. So the ones with the 4 in it are 4, 6, 4, 8. And then the ones which have got none of these is just 6, 8. Right? So you can fill in those two. Now, in each case, you have to ask yourself, what remains? And then you subtract, and you see whether the answer is 11. So suppose I put 2, 3 here, for instance. Right. So if those 2, 3 go in here, then in the remaining 3, you'll have 4, 6, and 8. Right? So that gives you 18 if you add them, and 18 minus 5, because 2 plus 3 is 5. And you can rule this out. Why? Because 13 is not a multiple of 11. So if I put 2, 3 here, it wouldn't work. None of those numbers will work because the remaining numbers will add to 18, and you can't get a multiple of 11. All right, so means now, let's add up all these things. You got 9, 15, 23. Rather than guessing, if you add up the sum of all, 5 equals 9, 15, 23. All right, so you got two groups, right? And they add up to 23. Suppose you got x and y here, so x plus y is 23. Because you're breaking up these 5 numbers into 2 groups, right? But you also want, you'll make x minus y to be either 0 or 11 or 22. The difference must be one of these. X minus y equals 0 means that x equals y, so we don't want the sum to be 0. It's not possible at all. But you can have a x minus y equals 11. So if x minus y equals 11, then you've got 2 equations and 2 unknowns. So if I add these 2, I get 2x equals 34, 23 plus 11, and x is equal to 17, right? If x is 17, it means that y is 6. So y, that's the sum of 2 numbers, is 6. So I must look for which 2 numbers add up to 6 here. You see, the mathematics allows you to eliminate guesses. That's beautiful. That's a nice thing about mathematics. See? So one group adds up to x, the other group adds up to y. You got 2 unknowns, and then you know that when you subtract them, you're going to get either 0 or 11 or some multiple. And then, so you can calculate x or y, but it turns out that it's easier to calculate y because it seems that these are the 2 numbers, 6. three numbers can't add up to 6. So the sum of the two numbers is 6, and immediately you have, those are the only two numbers which add up to 6, 2 and 4. All right. So I would have come to the answer straight away in the second case. But I've given you a general way of actually solving this problem without guessing. So you could have 2, 4. I could have 2, 4 here. Right. In that case, you got 6, and the remaining numbers add up to 17. Go all together, they add up to 23, and 17 minus 6 is 11. So any number which looks like this is divisible by 11. That's a very powerful statement. Any number which has got 2 and 4 there is divisible by 11. Now the question is, now how many such numbers are there altogether? Okay, we already got 2 and 4, so we need to fill in the remaining 3 numbers. You can't repeat because you want to write all these integers in the answer. Okay, so the remaining 3 numbers, the first number can be chosen in 3 ways, right? You got, the numbers are going to be 3, 6, and 8. You can choose this one here, 3 or 6 or 8. Once you choose this, you're not allowed to choose that number again. So the second number can be chosen in 2 ways. And once you choose those 2, then you only have 1 left. So altogether, there are 6 numbers in the slot here. Right? If you want to know what the 6 numbers are, it will be 3, 6, 8 in that order, 3, 6, 8. Or you could have, or make it 3 blank like that. Or you could have 3 blank, 8, 6. These 2 blanks are 2 and 4. Or you can start with 8. You can start with 3. Or you can start with 6. In which case you got 6, 3, 8 or 6, 8, 3. Or you can start with 8. 8 blank, 6 blank, 3. Or 8 blank, 3 blank, 6. So those are your 6 numbers. You can actually list the 6 numbers. Okay. So there are 6 numbers with this group. But be careful, because there is also, instead of putting 2, 4 in that order, I could have put down 4, 2. And that'll give you a new set of numbers. These also add up to 6. So there'll be another 6 here. The 6 there and the 6 there. So you can change these around in only 2 ways. You can either put 2, 4 or 4, 2. For this case, there are 6 numbers. For this case, there are 6 numbers. So the answer is that there are 12 such numbers. There are 12 integers using these numbers, which are divisible by 4. You can actually write the whole lot down. See, 3, 8, 6. That's one of them, is such a number. When you try dividing by 11, you will see it goes exactly. See, it goes exactly. In dividing this number by 11, you're going to get 2,986. I worked that thing out mentally quickly. So you've got like that. Any one of these numbers, you can put 638. Again, it will be a multiple of 11. So there are 6 numbers there and 6 numbers there. In all the cases, they will be divisible by 11. And none of the others are divisible because these are the only numbers where the difference between those 2 numbers is 11. By the way, the difference can't be 22. You might say, well, why? It could be 22, isn't it? Well, you can't have, you see, all these numbers, they add up to 23 already. So you got 2 groups, right? This is, each group has got, you can't have the difference being 22. The reason, because they add up to 23 already, right? So how can the difference be 22? See, if you have x plus y equals 23, and x minus y equals 22, right? Then when you add these, you'll have 2x equals 45. And that doesn't work because you want x to be a whole number. X can't be, 2x can't be 45. But then x is 22 and a half, not allowed. So 22 is out. So the only 11, 0 is out, 22 is out, so only 11 is allowable. And for that 11, by 11 I mean that the difference between these two sets of numbers is 11, right? That's the only one which is allowed. And in that case, there are 6 possibilities. All right, so that is a long and lengthy discussion that we had on divisibility by 11. Is quite interesting if you there are some nice shortcuts. Like, for instance, if I want to multiply 36 by 11, all I do is I put 3, 6, and add the 2. That's the answer. If I want to multiply, say, 62 by 11, I just put 6, 2, 6 plus 2 is 8. So there is an easy way. But in case the answer is more, for instance, if I had 7, 5 by 11, 7 plus 5 is 12. I can't put 12 in it, right? I must put 2 and carry 1. And then that becomes 8. See? So 75 times 11 equals 8. So you can put 7 and 5. 7 plus 5 is 12. So you have to put a 2 there and increase that by 8. By 1. So that's the answer. Anyway, that's just an aside. Short method of multiplying by 11. Okay, so let's just get on with the next problem. We go on to this one. How many 3-element subsets does a set have having 8 elements? Does a set having 8 elements have? All right, and this is a question on sets. Well, a set, just a set of objects. So you want to know how many subsets. A subset is something which is part of a set. Okay, let's take some examples here. If I do, suppose my set has got 8 elements. Don't take 8 elements. Say take 5 elements. 4, 16, 3, 1, 2. I'm taking a set of numbers. You can take a set of anything. You can take a set of pens or aeroplanes or whatever you like. But if I choose a set of numbers like this, now how many 3-element subsets are there? Yeah, then you can see, well, how do I list the 3-element subsets? The way to do that is just like what we did before, right? You list down all the 2-element subsets, right? And we saw that there were 10 of them. The 2-element subsets. We actually just list them down. And then you eliminate all the those pairs away. For instance, if I write down the 2-element 3, 2, right? Then that, if I take that out from there, I got 4, 16, and 1. Sorry. So every time I have a 3-element subset, if I take the what you call the complement, the remaining parts, that's the 2-element subset. So every pair of elements gives me a 3-element subset. So for instance, if I had 16, 1, why do I write 11 is 1? If I took 16, 1, then that corresponds to that. So every time I have a two-element subset, I have a three-element subset as well. So the number of three-element subsets is equal to the number of two-element subsets. By subsets, I mean a set having only two elements. I should put them in curly brackets like that. That subset. These are all subsets because they are part of this major set. Right? Number of three-element subsets equals number of two-element. Hope you understand that. Because you just have to take a two-element and that immediately, if you rub them out, then you got a three-element subset. And conversely, if you have any three-element subset, then the remaining parts is a two-element subset. So they've got the same number of elements. So the answer here is the number of three-element subsets if set has 5 elements, as in this example, is 10. Okay, but if you got 8 elements, that's not going to be that easy now. See? Okay, suppose I had 8 elements. Okay, let's take the same problem here. Now, I want us to argue as follows. Suppose I want to choose. So select a 3-element subset. Right. The way we did before. So you got, I'm going to choose the first number. The first number can be chosen in 5 ways. It could be 4 or 16 or 3 or 1 or 2. So there are 5 ways in which you choose the first one. The second one, you can choose in 4 ways. And once you choose the first one, if I choose the first one 16, the second one I can choose it from any one of 4, 3, 1, 4. Right? I'm not allowed to choose 16. Okay, so the second one can be chosen in 4 ways. And likewise, once you choose the first 2, if I choose 16 and 2, for instance, then the third one can be chosen as one of 4, 3, or 1. So that can be chosen in 3 ways. So we would have said the answer is 5 times 4 times 3, which is 60. But now that's obviously wrong because we just saw that there were 10. We didn't have 60. So what went wrong? That's an interesting thing to ponder over. The way we calculated this is what we did previously. First element can be chosen in so many ways, the second one can be chosen in so many ways, third one, and you get 60. But when you actually count them, you don't get 60, or you get 10. So there must be something wrong with the argument. And the question is, what is wrong with the argument? Okay, the answer is supposed to be 10, not 60, right? Now, I'll tell you what is wrong with it. You see, we could have chosen those 3 elements as, for instance, first element is, I've rubbed the thing out. First element is 18, 8, and the other one, I think I had 2 there as well, and maybe 1. I could have chosen it like that. Right? First element is 8, second is 2, third is 1. The problem is that this set here is the same as this. It's the same set. But we are counting this thing again in this count here. Right? This is where the first element is 8 and the second element is 1. Here the first element is 8 and the second element is 2. But we have counted this thing when we're not supposed to count it because it's the same set. See? Now, how many ways can you actually rewrite this set? You could have 8 in the first one, you could have 2, 8, 1, or you could have 2, 1, 8, or you could have 1, 8, 2, or you could have 1, 2, 8. So you can choose the first element as 8, or you could choose the first element as 2, or you could choose the first element as 1, and then once you choose the first element, then you can choose the second 2. Once you choose the first element, you can choose the second 2, 8, 1, 1, 8. And then once you choose the first element as 1, then you can choose the second 2, like that. So that's finished. There's no other way. So you are counting this thing 6 times. It's counted 6 times. In the 60 that we saw below. So every time you have a triple, that is counted 6 times. So you have to. So what's happened here is your 60 count. If you put them all in a group like this, the 8 to 1, there are 6 of these here, right? But you have to count this thing only once. You're not allowed to count all these. Like that now, you take all the different groups, right? If you take another triple, again, that'll give you another 6 counts, but you only count that once. So like that, what's happening here is that the 60, if you want to know the actual count, it's the 60 is divided up into several groups, each one having 6 elements, and we are counting all. So 60 over 6 gives you 10. You see? So we can get our 10. By observing that you can count, this thing here is counted 3 times 2 times 2, 3 times 2 times 1 way. See? So the actual answer here now, let's go to our problem. All right, if I chose the first element, could have chosen me in 8 ways. You'll see just now why I'm putting a line here. The second element in 7 ways, the third element in 6 ways. Then I've got that number of possible what we call arrangements, right? Because these are arranged in a particular way. The first one, second one, third one, right? But then we are counting, as we saw before, we're counting each of them by 3 times 2 times 1, right? You had a group of 3, and that set of 3, there are 6 arrangements amongst them. How do you get 6? The first one can be chosen in 3 ways, second one in 2 ways, and so on. So this is the answer to the question. You got altogether, you would have had 336 here when you multiply all these. But they are the whole set, the 336 total number of arrangements, but each one is counted 6 times. So you have to divide it by 6 to find out how many subsets you got. Because a subset 1, 2, 3 is the same as 3, 2, 1. The set has got the same elements. See? So therefore they must be the same. Right? This is a very interesting problem because it occurs many, many times. But you need not have 3. You need not have 8. The way I've described this thing now, you can answer any question if you think about it. Suppose I ask you, how many five-element subsets from a set having, say, 10 elements? Right? Suppose you have a subset having 5 elements, and your whole set has got 10 elements. So how do you work that out? Well, you'll say, well, let me just choose 5 from 10, but in a specific order. The first one is 10. The second one can be chosen in 9 ways. Third one can be chosen 8 ways. Fourth one in 7 ways. And the fifth one in 6 ways. You stop there because you want to just choose a set having 5 elements. But these 5 elements can be arranged, as we saw before, in this way. The first element can be chosen in 5 ways, 4 ways, 3 ways, 2 ways, 1 way, just like as we had that. See? So that's the answer. Very nice formula. 3 times 2 is 6, cancels off. 4 goes into 8 2 times. 5 goes into 10 2 times. So the answer is 2 times 9 times 2 times 7, which is 252. So there are 252 5-element subsets from a set having 10 elements. Okay. So like this, there are very, very number of problems that one can ask regarding this very important thing that I've just told you now. And I do hope you remember the argument, right? Not just the answer, not just the formula, but the argument that led to this thing. Okay, to the answer. I know I went through this thing quickly, but you guys are bright guys. I don't think you'll have any problems trying to understand the logic behind that answer. So that's the answer. The answer was 56 in this question. Let's get on to the next problem. Oh, this week's assignments, session 5. There are 2 problems here. Number 6 and 11. I've given you 2 problems. They are quite demanding, but try it. Try them and submit your answer, whatever it is. Even if you say, submit it to your lecturer and say, I tried, but I can't do it. At least do that. Then we know that you have attempted it. Right? I know that whoever is marking will say, what's wrong with this guy? But at least you would have shown that you tried and you failed. Or you try and get some answer which you know to be wrong, but it doesn't matter. Whatever argument you used, just put it down. See? And the second one looks very easy, but you will see that you will struggle with this thing because you've got, I'm going to just give you a hint. You see, you've got a triangle. Determine the perimeter of the indicated triangle. So you're given one side, but the 11 says this is the area. I should have been specific. Okay. Yeah, the question is not very well phrased. This is equal to the area. So the area of the triangle is given as 11. The hypotenuse is given as 10. And you're supposed to find the perimeter. Right? So in other words, if you are given, you don't know the two sides there, you see. So you have to find these two sides, A and B. So that you need to calculate A plus B plus 10. That'd be the perimeter. And as usual, we look for equations. And you can see, you can find, you know the area. So you have an equation there for the area. And you have a right angle triangle. So you got Pythagoras. And that gives you another equation. So you have two equations with those two unknowns, A and B. And you can try to solve those two equations. Unfortunately, guys, you can try to solve it, but you will find that you'll have great difficulty in solving two equations with two unknowns. These particular equations are a little bit complicated. They're not like the usual kind of equations. So then you would probably get stuck a little bit. Although you got two equations with two unknowns, you might get stuck. All right, so think about it. But the clue that I wanted to give you is that you are not asked to find A and B, you're asked to find the perimeter. So don't bother to try to find A and B. Go straight for the kill. Try to find the perimeter. Ask yourself, what must I find really? I don't really need to find A and B. Okay, so I'm giving you a nice hint there. I'm going to try it. All right, let's just go down to the next question. All right, so here, the next question is, a set has got 300 elements. How many subsets does it have altogether? Okay. Now that you can imagine, if you did what I told you to do, you say, well, I can count all the subsets. I'll look at all the subsets which have got no elements. That's empty set, by the way. Right? All the subsets which have got no elements, that is a subset. The subset which has got no elements, we normally write it down like this. Nothing in it. Right? And there's only one. So you can have a subset having only one element and no elements. Then you count the subsets which have got two elements. And as we saw just now, it's 300 times 299 over 2 times 1. The subsets having three elements. Of course, you have to add this. There's only one subset which has got no elements. These are all the one element subsets, what I call one element subset. That means a subset having one element. These are the two element. No, wait a minute. These are the two elements. Oh, I missed the one element subsets out. Okay, the one element subsets are easy because if you take all the subsets which have got exactly one element in it, there are only 300 of them. You can actually list them down easily. 300 sets which have got only one element. You just take each element and put a bracket around it, and that's, you can count there are 300 of them. Okay, so and then these are two element subsets and so on. Yes, by the way, you're going to go all the way up to 300. You'll die of old age if you were to calculate all that. So it's impossible. You can't do it like this. So there must be some other clever way of doing it. And I'll give you the clever way. It's a little bit abstract, but well, not really that abstract, but it's a very ingenious way of counting how many subsets there are altogether. Okay, let me, instead of putting 300 elements, that's too much. Let's try, say it's got 4 elements. We'll call this 300, say we call it n. N equals 300. Suppose n is equal to 4. Okay, then what you've got here is we want to choose a subset. I've got 4 elements, A, B, C, D. All right, now watch. I'm going to imagine that these 4 are boxes with on-off switch. Which lights the box or darkens it. And so these are boxes that got some switch in it, and you can put the switch on. I think it's light. If you don't put the switch on, then it's dark, right? Now I want to put these 4 elements inside here. I want to count. I want to create a subset, right? Let's make it a little bit more complicated. Not complicated, but more understandable. So suppose there are 8, n equals 8 here. Okay. Now, this is what I'm going to do. So suppose I pick a subset. These are your 8 elements. A, B, C, D, E, F, G, H. And suppose I pick a subset, say maybe B, D, E. Or maybe B, D, E, and H. When I pick a subset, what I'm going to do is I light this thing up. I'll put a tick there to show it's lit up. And this D is lit up, E is lit up, and H is lit up. So when I got these 4 lit things, then it means the subset that I'm talking about is B, D, E, H. Right. So what does this mean now? It means that no matter which subset I take, there is a lighting that takes place. If I took C, F, and G, for instance, then I will light up just the boxes which have got C, F, and G, right? And that will be the lighting that corresponds to that subset. So what does this mean? It means that instead of counting the subsets, I could take any subset. I count the number of ways in which these boxes can be lit. I'll repeat that. Instead of counting, each time I have a subset, I have a lighting that takes place. And every time I have a lighting, if I had this lighting, then I can tell you exactly what the subset is. So in other words, the lightings of the boxes correspond to a subset, to a particular subset. If I didn't light any boxes, that means it's got the empty subset, right? There's nothing in it. If I lit up all the boxes, then I've got the whole set, which is also a subset. See? So, like that now, every time I have a subset, I have a lighting that takes place. So the number of subsets, now that is a brilliant observation. The number of subsets I'll put like that, number of subsets equals the number of ways the boxes can be lit. Right. So now I'm going to find out in how many ways can you light up these 8 boxes. Okay. Now to do that, now this we can do easily. In how many ways can you light up these boxes? All right. The boxes are either lit up, or they are dark. There are only 2 ways in which the status of a box can be obtained. It's either light or dark. So the first box is either lit or it's dark. So there are 2 ways of doing it. This one is either lit or dark. There are 2 ways of doing that. And each one is either on or off. And there are 2 ways in which you can do that. So the total number of ways is here, it's 2 times 2 times 2, which is 2 to the power of 8. This is the number of ways in which you can light up the boxes. Number of ways boxes can be lit. And as we said, this is equal to the number of subsets. Right. So we've got the answer. The answer is 2 to the 8. I'm sure some of you know it's 256. So if I got 8 elements, the number of subsets is 2 to the power of 8. Right. You can try it. You can try writing down all the subsets of, say, A, B, C. Let's do that. Okay. Suppose I got only 3 elements, A, B, C. So let's list all the subsets. Okay. No elements. You got only the empty set. There's only one. One element. I'll put ELT for element. You can have A or B or C. Those are the 1 element subsets. The 2 element subsets, you can have AB, or you can have AC, or you can have BC. Right. You don't count AB and BA twice, right? Those are only 2. And the 3 element subsets, there's only 1, the whole thing. Right. So how many subsets? You got 1, 2, 3, 4, 5, 6, 7, 8. The number of subsets is 8. And that is 2 cubed. Right? You've got 3 elements. And what we said earlier on is that this is going to be 2 to the power of 3 subsets. So we actually listed it down, and we showed by that example that our formula is right, at least for 3. If you try listing for 4, you'll find that you got 16 subsets, right? That you can do. It's quite exciting to see that you work out all these subsets and you can count the 16 of them. Do that as an interesting exercise. But then you'll say, hey, I didn't have to list down all the subsets. I got a lovely formula. It's 2 to the power of 4. So the answer to this question here, if you got 300 elements, the answer is 2 to the power of 300. Yeah. So if you got a set having 300 elements, like for instance, if you got a school which has got 300 students, then you take any three, or any three, or any four, any five, or any 240 students. You take any group, right? Any possible subset, and how many possible subsets have you got? You have 2 to the power of 300. Now, I want to point out, say something about this number here. This 2 to the power of 300 is a very large number. Let me see if I got time to talk about that. I don't have time to talk about it. Oh, I spent too long over all these things. All right, let's get to the next question. The answer there is 2 to the power of 300. Let's have a look at the next question. You've got two parallelograms with perpendicular heights 5 and 10. Right. What do you mean by perpendicular height? In a parallelogram, the perpendicular height is nothing else but just if you got a parallelogram, sometimes they call it a palm. Perpendicular height is the distance between those two parallel lines. In other words, you take a point there and draw, both will be 90 degrees. Right. So this is the perpendicular height between these two parallel. But you have another perpendicular. If this is the base, then that becomes the height. But you could have had, if I choose this as the base, then the height now will be like that, you see. That's the distance between these two parallel lines. So you could have the height, or the height could be from one pair of parallel lines or the other pair. Okay, so that is why they say there are two possible heights. One is 5. If you take these two lines here, this is a height here, which is 5. And the other one, the other parallel line, the height is 10. This must be 90 degrees. Okay. But they overlap. Now, these two parallelograms, they're like sheets on a table, and they are, the one makes an angle of 30 degrees with the other. So they're not perpendicular. They're not like that. Right? They're slanted. Like that. Anyway, so the question is, what is the area of the shaded overlap? Okay. Now, the overlap is a parallelogram by itself, right? And so you need to find the area of a parallelogram. So how do you find the area of a parallelogram? There's a formula for the area of a parallelogram. I hope you know. It's equal to base times height. See, in the case of a triangle, it's half base times height. But in the case of a parallelogram, it's base times height. The reason being, you can break it up into two triangles. Both of them have got the area half base times height. So you had two halves, you get the whole parallelogram. You can check it out. So the area of a parallelogram is base times height. So let's have a look at this. This is base. Suppose I take this as base. The reason why I take this base is because I've got the height, you see. You see, this thing here, its height is 5. It's not easy to see. But the height is 5, and it's also 10. And also 10. because you got this. These parallel lines here, and if you take one point on this parallel line, this 10 here is the distance between these two parallel lines, right? These two. So it's the distance between the opposite sides of this parallelogram. Likewise, this height here is the distance between these two parallel lines. So it's the distance, it's the opposite sides, distance between the opposite sides of this parallelogram. So now you got the area is 10 times, sorry, you're going to have B times 5 is the area. So it's B times 5. Or you could have this thing here, let's call this one here A, this thing here. That's also equal to A times 10. You could have the other side of the parallelogram is A, but then the height is now 10. Right. But we don't know either B or A, but the fact that we got this is just this with 30 degrees, right? It allows you to actually calculate A. See? You got A here like this, and you got that distance is 90 degrees. It's 5, this is 30 degrees. See? This thing here, this 5 is actually, you can call it, you can take it from here to here. It's also 5. So you got a little right angle triangle here, with sides are 5. The hypotenuse is A. This angle is 30 degrees. And now you got, if you use your trigonometry, you will see that sine of 30 degrees is opposite of a hypotenuse, but sine of 30 degrees is a half. You should know that. So that tells you 5 over A is 1 over 2. If you cross multiply, A times 1 is equal to 5 times 2. So A is equal to 10. So you got that A is equal to 10. So the area now, you can work it out straight away, is 10 times 10. You don't need a calculator to work out 10 times 10. Right? Okay, because it's base, we just calculate the base to be A, and the height we already know. So the answer to that problem is 100. Okay, I took too long over the other one, so I'm going to kind of rush through these. Uh, the next problem is this one. The diagram shows a rectangle inside a semicircle. Okay, and the two vertices of the rectangle, as you can see, lie on the semicircle. So this vertex, two vertices of the rectangle, it lies on the semicircle, right? And the two lengths are shown. This is 1 here and this is 4. And again, you're asked to find the area. Very often, the area problems are given instead of asking a geometry problem, but you use a lot of geometry to find the area. So that is why these area problems, they look as if they're easy, you have to find the area, but there's geometry involved in it. Okay. So now we have to find the area of the rectangle. Okay. So the area of a rectangle is length times breadth. You got 4 is one of them. So we need to find out that one. It's 4B. Right. So how do you find B now? Okay, now that's a little bit tricky because, well, by symmetry, you can see this one here will be 1 also. So let's call this thing B. Then you can see the diameter is b plus 2. If that is 1, this is 1. And therefore the radius will be b plus 2 divided by 2. Now, why do I worry about the radius now? You see, I can actually, if I take the center, this is 90 degrees because it's a rectangle. And if I join it, and when you study this problem, you'll see you might have to do all this. When I join it to that, then I'm going to get the radius, you see. But then you've got a little right angle triangle. So let's call this thing R. Okay, so let's actually find the radius, and then from there we'll be able to work out what B is, right? I'll work out the radius. Let's call this radius. That's your R. That's the hypotenuse of this right angle triangle. The radius of the circle. The distance from the center of the circle to the boundary is the radius. Now, the radius is also this. The distance from the center to the boundary. So the other part of the right angle triangle is actually R minus 1. Now, that's an interesting one, because the whole thing is R, and this is 1. So this is R minus 1. And the third one is 4. So you got, in this right angle triangle, you see you got one unknown, because the radius, using Pythagoras, the square and the hypotenuse is equal to R minus 1 all squared plus 4 squared. This squared plus that squared. Okay. And that allows you to calculate R. Right. If you work this whole thing out, you get that 2R is actually equal to 17. Right. Now, I'm not working out R, but 2R are recognized to be the diameter. So there's the diameter. Right? The diameter was B plus 2, and that is 17. Twice the radius. Right? And now that allows you to work out B very quickly. So B is 15. And that's nice. So the area is 4 times 15, which is 60. Right. So you have to get down to try to understand this and see what must you actually calculate. And if you find the radius, then you can find the diameter, and then you can find the diameter, you can find this other side, and you're on your way. Okay. Okay, I'm sorry, I actually ran out of time. I'll do one more. There are 2 problems left, but I'll just do one more because I don't want to abuse you. I took too long over these subsets and all that. I thought I had a lot of time, but obviously I didn't. So I'm skipping one problem and I'm going to the last problem because that wouldn't take too long. Now, the figure shows 4 semicircles. Again, it's an area problem. You have to find the area of the shaded region. Right. So this is a very funny looking shape here to find the area of this yellow part. But then if you think of it, it might not be easy to find the yellow part, but it might be easier to find the white part, because the white part, you've got 3 semicircles, and you know how to find the area of a circle. So half a circle you can find, and that too you can find. So you can find the area of the white part, and you can find the area of the whole semicircle, because given that the radius is 2, you see, shows you 4 semicircles, one with radius 2 centimeters. So this is 2, you see. All right, so you've got the radius of the small circle, and you got also the radius of the large circle, because this is the center. Right? You can see you got 4 this way, 4 this way, so this has to be the center. So you can calculate the area of that and the area of that and the area of that. But then you got this funny looking thing here and you don't know how to find the area of that. So that's a problem, right? When you try to do it like this, you have a problem. But if you think carefully about it, you'll say, wait a minute, I don't know how to find the area of that, but I can do something. Like I can draw a perpendicular here. I can draw a perpendicular here, right? Now that way, I can take the white part, the white area, or the so-called unshaded area. You can actually calculate the unshaded area. Why? Because you now divided it up into 4 pieces, one of which is a rectangle, and this is half a circle. This is half a circle. I'm sorry, this is a quarter of a circle. This is a quarter of a circle, and that is half a circle. So these 3 parts here, 2 quarters and a half, gives you the whole circle, equals the whole circle. When we say whole circle, you mean the whole circle of radius 2. So it's pi times the radius of a circle with radius 2 is pi r squared. So the r for this is pi r squared. Now this quantity gives you the area of that piece, and that piece, and the 2/4 circle and the half circle. But the other one is just a rectangle. And the rectangle, this part here is, the height is the same as the radius, as you can see. So the area of the rectangle is length times breadth, which is 8. 4 times 2. So it's 4 pi plus 8. So the area of the unshaded part is 4 pi plus 8. And the area of the shaded part is equal to the full area minus the unshaded. The full area is half a circle. So it's half the circle whose radius is 4. Right? So it's half of pi times 4 squared. That is the area of the full circle here. But we only want half that, because then I have to take the entire circle and subtract from it the area of the unshaded part, and that will give you the area of the shaded part. See? So you actually have 4 pi minus 8, something like that. Okay, I'm sorry, I've gone once again 8 minutes into your free time, and I thank the 9 people who remained behind for remaining here. I'm going to if you want to go, please do that. But for my own satisfaction, I want to just finish that last one. If you want to remain, feel free to do that. And I just want to apologize to you that I went beyond my time. Okay, but I'm going to do that one remaining part. The remaining, the one question which remained was this one here. Okay, and this is a pretty tricky question. It says ABCD is a rectangle. Again, this is an area problem. AB equal to 8. One side is given. Oh, and the other side is also given. So that's nice. So the dimensions of the full rectangle are given, 8 and 14. Now you've got a strip of width 2. Now this is a parallelogram, right? As you can see, these 2 lines are parallel, and the width 2. So, okay, we saw this thing earlier on. We can calculate the area of this parallelogram. Right? Determine the maximum area of the strip. So if I call this X, that's the side of the parallelogram, and This is the height. So the area of the palm, as we saw earlier on, is equal to base times height. So it's 2x. Right. But they want the maximum area of the strip. You see, you can draw a strip like this with a height 2. Right. Now, how can you find the maximum area? The height is always going to be 2. So you want to see when is x the largest. That's then only you will get the largest possible area of the palm. So which of these, if I take a point on this line and take a point on this line, right, which x will give me the largest possible x? So if you think about that, if you think about that carefully, you will see that the largest possible x will have to occur. X is the distance between a point on that line and a point on that line. So which 2 points will give me the largest possible distance? That is really the thing. And that will give you the maximum area that we are looking for. And the answer to that question is I have to choose one here, right? And then I have to choose this line to be, I can't go all the way up there because the distance, I have to go somewhere there. And then from here again, like that. But the height will still be 2. That obviously is going to be the largest possible x. This gives you the maximum x. Right? So this is x here. This is x, maximum x. So that will give me the area that I'm looking for. Okay, now, what is this x here? Well, we already know that this is 14 and this is 8. So this is O. Now this is, we have to be a little bit careful. This we can call this x. Let's call this y here. Okay, this part here. So this is 14 minus make this y. And this part here will be 14 minus y. So this part here is y. So you get 8 squared plus y squared is x squared, right? So you get 64 plus y squared is x squared. Okay. Now, so the area that we're looking for is 2x. You see, the height of this, the area of this parallelogram, it can be obtained in 2 ways. Here's a very, very important fact. What is the area of the parallelogram? The area is, if I'm calling this thing 14 minus y, right? 14 minus y, the height is 8, you see. So 14 minus y times 8 is the area of this parallelogram. Right? So it's 14 minus y. The height is from there to there. The height between these 2 parallel lines, which we already know, this parallel line and that parallel line is 8. But you can use this other base to find the area, which we already saw. That's 2x. So we got a nice, lovely equation involving 14y and x. So you see that x is actually equal to 4 into 14 minus y. Cancel the 2's. So you can substitute the x here, and you can get 4 into 14 minus y all squared. See? And then you got a single equation involving y, and that will help you solve the problem. Okay, that it looks rather complicated, but I think if I used X here, Y here, then it would have been easier. If I chose Y to be this, then I don't have a complicated equation. I would have, if I made this Y, and that is 14 minus X, then I'll have a nice equation. I'll have Y times 8 equals 2 times X. So I'll get X is equal to 4Y. And that is much easier to work with. See? So you can try this problem. Again, it's a demanding problem. And thank you for your attention. Okay. I took too long over this session. Thank you very much for your patience, guys. Okay, there's 6 people left, and I want to thank you for remaining there to the end. David, I'm sorry, man. I keep taking your time over and over again. Okay, we're going to stop the share now, and you're going to close the session. Hi, David. Are you there? Or are you gone?
No, yes, I'm here, Prof.
Oh, God. I'm sorry, man. I keep abusing you. You're always so patient and you wait. Instead of finishing off at a appointed time, I make you work.